In this section, we're going to cover these four different topics, starting with discussing the four quadrants in the XY plane, the distance formula, the midpoint formula, and the equations of circles. And so to start off, let's look at the XY plane. Sometimes this is referred to as using what are called Cartesian coordinates. And these are sort of the standard modern coordinate system that's used in a lot of graphing situations. For instance, if we had a point 2, 3, then that would refer to this point right here with the x-coordinate of 2 and the y-coordinate of 3. Similarly, you could have a negative number for the y-coordinate like 2, -3. It would go down here instead. Or x could be negative. You could have -2, 3, or down here it would look like -2, -3. And so it's a way of plotting points and drawing graphs and doing stuff like that. What we're going to use most of all, though, within the Cartesian coordinate system is talking about the four quadrants. And so the way we label our coordinates is the first quadrant is here, the second quadrant is over on this side, and then we have the third quadrant, and finally the fourth quadrant. Sometimes they use the Roman numerals for 1, 2, 3, 4 here to label the four quadrants. And so the thing that we want to highlight about the different quadrants are what sign does the values of x and y take in each quadrant. For instance, in the first quadrant, we see x is a positive number and y is a positive number. But in the second quadrant, x is a negative, y is a positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive and y is negative. So sometimes I say like quadrant 1, we could say that x is greater than 0 and y is greater than 0 since they're both positive. In quadrant 2, x is less than 0 and y is greater than 0. Quadrant 3, we see that x is less than 0 and y is less than 0. And then finally, quadrant 4, x is greater than 0 and y is less than 0. So what I'd like to do here for our first example is to consider the product of x times y when both x and y are in coordinates from the second quadrant. So what that means for us is for the second quadrant, quadrant 2, again, x is negative and y is positive. So that means that our x multiplied by y would look something like a negative times a positive, and a negative times a positive would be negative. So we don't know what the numbers are for these, but we know it would have to be a negative value as a result. So what if we took a look, though, at quadrant 3 and considered dividing x over y? What kind of value would we have? Would we get a positive or a negative? Well, we considered for quadrant 3 that x and y are both negative. And so that's going to tell us that x over y would look like a negative divided by a negative, which is a positive. So no matter what x and y values have, as long as they're both coming from a quadrant 3 point, it's going to be a positive value when we do x divided by y. And so kind of giving us some more things to do here with the coordinates, let's look at some sets that specify what x has to be. In this case, it says plot the sets where we have the coordinates x, y, and we're going to start out with the one that says the absolute value of x is greater than or equal to 2. Now, something that we know about absolute values is if you have an absolute value greater than a number, kind of like what we do here, we can actually rewrite that in a slightly different way. This means that x itself is less than or equal to -2, or x is greater than or equal to 2. And why I can say this is, since if we had the absolute value of x greater than or equal to a number like c, that means x is less than or equal to -c, or x is greater than or equal to +c. So we're always going to be able to take an absolute value statement like this one and rewrite it into a different way to help us understand what it's actually meaning here. So what I'm going to do here is I'm going to look at this set here of x comma y such that the absolute value of x is greater than or equal to 2. And I'll, rather than this, think of it as the set of coordinates x, y with an x less than or equal to -2 or an x greater than or equal to +2. So if we lay out our xy axis here, our xy plane, and then consider what part of this the set is going to be covering, think about x on the positive side with +2 and on the negative side with -2. It's telling us that it has to be less than -2, greater than +2. So if I look at the greater than side, I'm just going to be looking at this side over here. That's where x will be greater than 2 or equal to. And then the less than side of -2 would be over here on the left. So I'll just kind of shade that area in over here to indicate that that's the part that it's including. So this is the part where x is less than or equal to -2, and over here greater than or equal to +2. And so that's what this set is going to be referring to. This side on the right and this side on the left for -2 and +2. Now if we look at this example for this set of x comma y, where the absolute value of x is less than 1. Let's see what that represents here. Well, for this one, if we use the absolute value of x is less than a number, then what that's going to mean is that -c is less than x, less than c. The difference of this one between what we did in the last thing was this is a less than rather than a greater than. So when you have an absolute value less than a number like c, it turns into this thing here. So that's what I'm going to change the set into. I'm going to change this into the set of x comma y such that -1 is less than x less than 1. So now the x value sits between the two values that we have here, between negative and +1. So to draw this, what I'll do is I'll lay out the xy axis, and then we got the +1 on this side and -1 on the other side. And in this case, it sits between the two numbers. So the area I'll shade in is this area right here. All right, and so that represents the set of all x, where x is greater than -1, but less than +1. Now next we'll discuss something called the distance formula, which again is directly related to our xy coordinates. And so for the distance formula, let's say we have 2 points here in the xy plane. We'll label them x1, y1, and x2, y2. What the distance formula is going to tell us is how far it is between these 2 points on a straight line. So the straight line distance between the 2 points. I'm going to call this distance d. And so the distance formula, the way it's calculated is we're going to use this letter d equals, for distance, the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And the first thing I'm going to do with the distance formula to show how it works is let's consider these 3 points, 1, negative 2, 8, 9, and which ones are closer to the point 5, 3. Okay, so here's how we're going to do this. We're going to go ahead and check how far it is between the points and see which one comes out to be the smallest. And whatever's the smallest has the smallest distance and thus has to be the closer of the 2 points. So let's start out here by finding the distance from 1, negative 2 to 5, 3 using our distance formula. So this will be our x1, our y1, our x2, and our y2. And the distance formula would go the square root of 5 minus 1 all squared plus 3 minus negative 2 all squared. All right, and that's going to be equal to 5 minus 1 will be 4 raised to the second power. And then 3 minus negative 2 is going to be 3 plus 2. 3 plus 2 would give us 5, here raised to the second power. Okay, so 4 squared, that's 16. 5 squared, 25. Add them together, we get the square root of 41. And so the square root of 41 is just going to be our number for the distance here. We could always use it as a decimal if we want to approximate it. I'm going to leave it as is for now and see what happens when I find the distance for the other point. So we're going to take the distance from 8, 9 to 5, 3. Now, if you'd like to do a practice run of this formula, you may want to pause the video here for just a second, plug the numbers in like I did up above, and see what you find for the distance. What I did here is I took square root. We could call this one x1, that one y1, x2, and y2. So if I use those numbers, it'd be 5 minus 8, all raised to the second power, plus 3 minus 9, all raised to the second power. And either order that I put these numbers in will work. It just so happened I put them in this order here. So this would look something like negative 3 squared plus negative 6 squared. And that would turn into 9 plus 36. And so square root 45. And so now we can tell which one is bigger and which one is smaller. The square root of 41 would be the smaller of the two, and therefore has the shortest distance away from that point. So we can say that the point 1, negative 2 is closer to the point 5, 3. All right, now let's take a look at another formula called the midpoint formula. Kind of similar to what we were doing with the distance formula, we're going to have 2 points, x1, y1, and x2, y2. But rather than calculating the distance between these 2 points, we just want to find the point right down the middle that's equally distant from both of the 2 points. And so the midpoint would be right here, let's say, and we're going to use the capital letter M to stand for the midpoint. And so our formula that finds this midpoint halfway between the two is capital M is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now the example we're going to use with the midpoint formula looks like this. We're going to have 4 points given here to us. And these 4 points make up a shape. They call it a quadrilateral, 4-sided shape. And we're going to figure out that that shape is technically what they call a parallelogram, by checking the midpoints and showing that the diagonals in this shape bisect each other. So what I'm going to do here first is start plotting the points that we have, starting with that one 1, 2, be somewhere down here. We have another one that says 4, 4, so that'd be somewhere over here. We have a point 5, 9, which would be way up here. And then another one that says 2, 7, so that'd be somewhere around here. All right, so the shape we're building, if we connect the dots like this, that's what they call the quadrilateral. And we want to show that the sides basically are parallel, like a parallelogram. And what we're going to do is basically think about what they call diagonals here, connecting opposite points. Figure out if they meet there in the middle at the midpoint. So the way we can do that is by using the midpoint formula. So what I'll do here is figure out the midpoint between starting with 1, 2 and 5, 9. So this will look like our x1, y1, x2, y2. So the midpoint here would go something like 1 plus 5 over 2, 2 plus 9 over 2. And so that would look like 6 over 2, 11 over 2, or 3 over, or just 3, I should say, and 11 over 2. So that's what midpoint we see between those 2 points. And if we go on and we check the midpoint between the other two, 4, 4, and 2, 7, that midpoint would start off with 4 plus 2 divided by 2, 4 plus 7 divided by 2. We check the numbers, that'd be 6 over 2, 11 over 2. And so indeed, we'll just have 3, 11 over 2. So we see we get the same midpoint between those opposing coordinates. And so indeed, it does show to us that this is a parallelogram. As long as both meet at the same point in the middle, they do what they say up here is bisecting each other, and so it works out the way that we would expect. So next shape let's talk about is a circle, and in this particular situation we're actually going to figure out what the equation is for this circle. So if we're just looking at a circle here, but we're considering that it's inside the xy plane, we're going to start figuring out what parts we can label and what the equation will turn into. So for instance, first off, the center of our circle, let's give it the coordinates h, k. H for the x and k for the y coordinate. And then another important part of a circle is its radius. So we're going to use r to stand in for its radius coming from the center onto the circumference of it. And then that point on the circumference, we'll call that x, y. And so the equation that we get here for this circle goes r squared equals x minus h all squared plus y minus k all squared. So that takes into account all the different things, the h and k for the center, the r for the radius, and then x and y can be any numbers that exist on the circle itself. So let's go through a few examples of equations of circles and try to figure out some of the different parts of them. Let's start out with this one here that goes x squared plus y squared is equal to 25. What I want to do is graph this particular equation, this particular circle. So if we look at this thing, which is x and y itself, compare it to the graph of a circle, notice that we don't see numbers for h and k. So basically, it kind of works out to be something like x minus 0 and y minus 0. Since There's really no numbers there. So what that tells us about h and k is our h comma k is going to be 0 and comma 0. So that's our center. And so if we look at this number here for 25, that's our r squared. R squared is 25, which means that the r has to be just the number 5. And so that's our radius of our circle. So now we know the center is 0, 0, and radius is 5. What we can do is draw a picture of this in our xy plane. Now the center 0, 0 is right here where the x and y axis meet each other, otherwise known as the origin. And then from there we can go out radius of 5. And then just kind of draw the circle best we can with that particular radius. So here's another equation that looks like the equation of a circle, but this one we're actually going to have numbers for h and for k. So let's figure out what those are. Notice how we have a -2 here with x minus 2 and a +2 for y plus 2. And so those are in the places where h and k are. What I often recommend doing here is to just set these equal to 0, x minus 2 equal to 0, y plus 2 equal to 0, and if we add the 2 over, we'd have equal to positive 2, and if we subtract the 2 on the other one, we get a -2. Those are going to refer to the numbers for h and k. So in this case, h is positive 2, and k is -2. So what we're going to be able to say here is that the center of our circle, h comma k, is going to be 2 comma -2 in this case. And then for the radius, we look at that number 16 over here. That's our r squared. R squared is 16, and so our radius would need to be 4 in this case. So if I'm going to sketch this, I'll take the radius and take the center, and that'll allow me to draw the graph. We find our center at 2 comma -2 down here. And we'll just do our best to try to kind of consider a radius of 4 in this case. Somewhere out there about is where our radius should be. So just a best circle shape. Doesn't have to be perfect. We're just doing this by hand, so maybe something close. We'll try one more time. Maybe one more time. We'll get there. Something close to that is good enough for what we're trying to do here. So we got the radius of 4. We got our center at 2, -2. So that's about all we need to do here. All right, now in this example, we're going to take it one step further, and what we're going to do is actually find the equation for the circle. So we're not starting with the equation here, but we're going to use some points to help us figure that out. And these 2 points here, 1 comma 8 and 5 comma -6, it says, are the endpoints of the diameter of the circle. Okay, so let's see how we can make this happen. All right, let's start out with the points that we have here. We have the point 1 comma 8 and 5 comma -6. And it's telling us that these are the endpoints of the diameter of the circle. So what that means is our circle is going to kind of go around like this here. Okay, looks something close to that. Well, we know that's about all we know at the moment. We'd like to know the equation, again, of the circle. The equation of the circle is going to have the x minus h squared plus the y minus k squared equals r squared. So what I'd like to be able to do to fill out this equation is find the center, the h comma k, and I like to find the radius, r, to put within that equation. So can we do that with information that we have? One thing we can figure out fairly quick is we can get the center by just finding the midpoint between the two ends of the diameter. So we'll just go right over to our midpoint formula. M is equal to be 1 plus 5 divided by 2, and 8 plus negative 6 divided by 2, which is going to turn into 3, 1. So that's our h comma k center for the circle. Now for the radius, what I'll do is I'll look at the midpoint, which we just figured out right here, the center, and I'll use that to figure out the radius by figuring out the distance between the center and either of the endpoints on the diameter here. So either one of those would work. So what I'm going to do here is I'll find the distance from the 1, 8 to the 3, 1 to get to the radius. So going back to our distance formula, what this would look like is square root of 3 minus 1 all squared plus 1 minus 8 all squared. So that would turn into this 4 plus 49, and the square root of that would give us the square root of 53. So that is our radius here. So the equation are go x minus 3 squared plus y minus 1 squared, and then the r is going to be r squared, so 53 square root of that raised to the second power. So what that would mean is instead of square root of 53, we'd actually just get the regular 53 here. So that'd be the equation of the circle in this case. All right, now on this example here, it says show that this equation is the equation of a circle and find the center and radius. Now you might notice that this equation doesn't look anything like the ones we've seen so far. It's quite a bit different, but there is actually a way of taking this and making it into the equation of a circle. So just keep in mind the equation of a circle was again x minus h squared plus y minus k squared equals r squared. So what I'm going to do first is I'm going to rearrange this equation just a little bit. So I'm going to put x squared, and then I'll put the plus 2x, and then I'll put the y squared and the minus 6y, and I'm going to move that 7 over to the other side of the equation so that it looks like equals negative 7 instead. Now you might notice I left some blanks in here, and that was intentional. I want to put some numbers and fill in those areas. And we're going to be using a process called completing the square to add some additional numbers in here to make it work out what we're trying to do. So we complete the square. What we're going to do is take these numbers that are in front of the x and the y. So the first thing I'm going to do with those numbers is I'm going to take 1/2. So I'm going to take 1/2 of 2 to get 1. I'll take 1/2 of negative 6 to get 3. And the second step of completing the square is to actually square the numbers. So once I found out a 1, I take 1 and I raise it to the second power to get still positive 1. Over here with the 1/2 of negative 6, that's equal to negative 3. So I take that number, the negative 3, raise it to the second power, and I get positive 9. So these are the numbers that I was trying to get to. I take those numbers and put them up here in the equation as a plus 1 and as a plus 9. Okay, and then I still have to put those on the other side of the equation as well. So plus 1, plus 9. Okay, now what this allows me to do is take this equation, and what I can do is put them together as two of what we would call trinomials, because now there are 3 terms apiece. And on the other side of the equation, it's negative 7 plus 1 plus 9, which would be 3. Okay, and so what we can do here is we can factor the groups of 3 terms each, the trinomials here. The first one, x squared plus 2x plus 1, would factor to be x plus 1 times x plus 1. The other one would factor to be y minus 3 times y minus 3. So what that changes into is x plus 1 raised to the second power plus y minus 3 raised to the second power is equal to 3. So now we can tell that this is indeed the equation of a circle after doing all these steps to complete the square and factor. Our h comma k, our h would be negative 1, our k would be positive 3. Notice how r squared is 3, and so r would be the square root of 3. So we'll say that the center of our circle is negative 1 comma 3, and our radius of our circle would be the square root of 3.